We are discussing remote sensing. In this remote sensing principles, we are taking MCQs. We'll try to understand this concept using these MCQs. The first is the relationship or relation between velocity, wavelength and frequency can be given as. So what is the answer here? The answer is B. How? Whichever wave you take, even if you can take a rope, you can see the waves in sea. All these have the same form like this. So this is how it travels. Energy propagates. If you want to understand this, we can have a mean line. A mean, this is a mean, and this wave is going up and down. The maximum extent it can go is amplitude. Two peaks, the distance between them are from two starting points where it starts or coming up or going down. So the distance between them, all these are wavelength given by lambda, wavelength. Now third thing is speed, velocity of propagation, and one more thing is frequency. 1 second, how many hops, how many ups and downs it creates or it travels. So this is higher in 1 second, and more higher, this is the higher frequency. And this is the lower frequency because there is only one quarter of the wave. So this lambda equals C by F. If you write this and multiply cross multiplication, C will be equal to lambda into F. Lambda is the wavelength, F is the, or nu is the frequency. Next is remote sensing uses which of the following waves in its procedure. So whenever we do remote sensing, that is, we are sensing the object, understanding the object without contacting it. So which waves are important in this case? The answer is electromagnetic waves. Electromagnetic waves, in this remote sensing uses these waves. First, the different waves present in the electromagnetic spectrum. We will be talking about the spectrum just now. So in electromagnetic spectrum, we have different lambda representing different frequency, and these are created by electro and magnetic field. That is, the electromagnetic fields, electric, that is current, which in normal language you understand, magnetism. So electric and magnetic field, because of this, the waves which create, if you see here, the electric field is perpendicular. The magnetic field is horizontal. These are orthogonal, that is, they are at 90 degree. So this is how the wave travels, waveform is generated, and this wave are electromagnetic waves. It's a big science by itself. So I'm giving you a layman idea, electromagnetic waves. In remote sensing, see, as I was saying, that there is an electromagnetic spectrum. That is the range of frequencies we have, and that is limited. So this range is a visible light beyond which you cannot see. For example, X-rays you cannot see, ultraviolet you cannot see, and the other waves also, infrared, you cannot see. You can feel the heat, but you cannot see the wave. That is not comprehensible by the naked eyes. The naked eyes can only see that part visible. Others are also there, and that can be sensed. Which of the following is not a principle of remote sensing? So, not a principle of remote sensing. The answer is interaction of energy with satellite. Though one form it is, but electromagnetic energy is definitely a principle. Even if you take this active or passive, so it has to send and receive passive, it has to receive some form of energy so that it can sense, it can image, right? Then the electromagnetic spectrum, as I said, the electromagnetic spectrum has different part. So some sensor, some satellite, they image in infrared, some in visible light, some visible range, some in, say, a different range. So other different ranges are there. So from here to here, it's an electromagnetic spectrum that I'm coming just now. Then interaction of energy with atmosphere is also important. See, the energy is coming from some source. It interacts with the different objects here. We have different layers: troposphere, stratosphere, mesosphere, and thermosphere and exosphere. All these have different ions, layers, formations, formulations. So this interaction of energy with atmosphere is there. So answer is, interaction of energy with satellite is not a principle. It's not a principle. It is a process. It is a process definitely, but not a principle. Other three are proper principles of remote sensing. So energy is, interaction is not there. It's just a sensing. A if you say. Which among the following waves is having less wavelength range? Less wavelength range. I was trying to tell you earlier about the spectrum. Kilometer is a higher units. That is, 1 kilometer is around 1000 meter. Then of course meter is lower, 1 by 1000 of a kilometer. Millimeter is 1 by 1000 of meter. And nanometer is 1 by 10 to the power 9. That is, if you compare it with meter, it is 10 to the power 9 meter. Nanometer is 10 to the power minus 9. That is, if you divide meter by 10 to the power 9, then nanometer will come. So which is having the least one? Nanometer. Least is nanometer. This is the electromagnetic spectrum. Wavelength always increase from left to right. You can see also the wavelength is increasing. And the lambda, wherever it increases, the frequency will decrease, because lambda is inversely proportional to the frequency. It is inversely proportional. So when, as I was saying, that there is a very small range of visible light which we human can see. There are so many animals which can see beyond this also. For example, the snake, it only senses heat. उसको केवल गर्मी दिखाई देती है. So he or it you can say attacks only because of the infrared. It has no eyes, normal visible range. In visible region, the blue light is having a wavelength range of. So we just talked about the electromagnetic spectrum, and if you see a small part of visible light, it starts with just prior to 400 nanometer and goes after 700 nanometer. This is the only range, and here we have every color. I am just showing you blue, yellow, red, just to signify that blue comes first and red comes last. But if you see here, the left blue starts at 400 nanometer, just prior to 400 nanometer. This is 400 nanometer. And how to convert this into nanometer? See, nanometer is 10 to the power 9 meter, and micrometer is 10 to the power minus 6 meter. So just divided by 1000, it will be some 0.4 something, but it will just be prior to 0.4. It's A and C can be answered, but the actual answer is A. Others also you can see what is the range. Which of the following field is used by the electromagnetic waves? Which field? So electromagnetic name is electro and magnetic. So this already I showed you, electric and magnetic. So we don't have any other except electric field here. So electric field, we are going to say it is the correct. See, electromagnetic waves have two major source of field, electric and magnetic, and as I said, they are orthogonal to each other. Electromagnetic, orthogonal, perpendicular to each other. This is a wave pattern which is formed because of the orthogonality. The electric components are placed in a vertical manner. This is electric, vertical, and this is a magnetic component. These are on horizontal manner. B, represented by B. And also we have arrow on E and B because it's a vector quantity. Among the following, which describes Stefan Boltzmann formula? If you see here, I have an example also just to let you understand. The Stefan Boltzmann law is basically based on the radiation produced and emitted by the body. That is, a body is creating, producing, emitting, because it absorbs and then it emits. For example, a utensil, making bread or anything which is heated, it will liberate, it will emit certain energy that is in the heat form. So this can be mathematically represented by m equals sigma t to the power 4. M equals sigma t to the power 4. And here we have this, of course, sigma, there is a constant here. So this one is the Boltzmann constant, T is the absolute temperature, and M is what? M is the spectral excitance of the body, how much it emits or the production is there. I'll give an example to better understand this. For example, sun has a temperature, surface temperature as 5800 Kelvin. Its radius is 6.96 into 10 to the power 8. Calculate the power output. In order to power, you have to have an area also. So a sphere, the surface area of a sphere, sun is a sphere. So 4 pi r square. The sigma we are using, as I told you, we are using this, and then T, temperature is 5800. So in this formula, we always use temperature in Kelvin. Which of the following is not a classification of scattering principle? Scattering is what? Scattering is whenever a wave or light, it interacts with certain object, it scatters, it changes its path, or has some formation. For example, lambda of this light, if the particle is smaller than it, equal to it, or larger than it, then the scattering will be different. For example, Rayleigh, Mie, and non-selective scattering. Non-selective means Mie scattering larger particles. So 3 types of scattering we know: Rayleigh, Mie, and non-selective scattering. But here we have Faraday's scattering, which is not the scattering which we know. So B, C, D are correct answer, which is not. So A is the correct answer. It is not the classification of scattering principle. Okay. Which of the following can act as an example of airborne platform? Airborne platform. Airborne is some platform in the air. For example, aircrafts. For example, you have a balloon. These are all airborne. If you go to water, it will be waterborne. If you are standing on the ground, it's a, say, soil-borne or ground-borne. So at present we have airborne platform as Dakota, Aviaro, and Beechcraft. These are different airborne things you are able to see. It's like sensing from the place where you can see the ground, you can sense the ground. And the answer is Dakota, because these 3 MOS and these 2, they are not airborne, they are satellite borne. Polar orbiting satellite are generally placed at an altitude range of. So whenever we launch something, for example, ISRO launches or American Space Agency does it, they say PSLV launch, GSLV launch, that is Polar's satellite launch vehicle, and geostationary satellite launch vehicle. Why the names are like this? This is because the answer is C, by the way. If you see it very closely, if you place anything in the orbit and that orbit length decides where, or the orbit diameter, or from the distance from the Earth, that decides whether it is polar or geo. So if you see sun synchronous, sun synchronous means you will see at the same time that satellite or that object every time at the same time at the place. The farthest is the geostationary satellite, that is around 36,000 we generally speak in order to remember it, but it is 35,800 kilometers. This is geostationary orbit. It has the same orbit time as Earth. Then we have the polar orbit, that is 200 to 1000 kilometers it is. Since this is an idea, but if you see in C, there is a range which fits with polar orbit. That is why the answer is C. So these were certain questions of this topic. Thank you so much. Take care of yourself.